what my work would be.
Stop! Okay, we're gonna have actually 2 videos that you're uploading because I accidentally pressed the button.
This is why I prefer Danielle to do it, because she's not a screw-up.
No, her arms got all sore, so then I did it. But then when I moved my finger, I barely touched it. Okay.
Are we not ready?
Okay.
Are we ready?
Hold on. Guys, there's 2 videos because I'm a screw-up. Blame my parents. We're good.
Okay, so let's look. How can I find what my work would be? I started with, I put in 100 joules of energy. So to get my net work, my QH would be 100. The amount of heat that's leaving my engine is 80 joules. That would be my QC, or the heat that's coming out. So then to find the net work, I just take 100 minus 80, so I should be left with 20 joules. Okay, so hopefully this makes sense. Now there's another way that we can find the thermal, there's another way that we can write this thermal efficiency. Every time, as long as you just use it as your thermal efficiency is equal to the net work over the amount of heat put in, all of this is just a rearranged equation of that. So we see the same things here. I have my net work, the amount of work that I've done, the amount of work that my engine has done, over the heat that I've put in, the energy that I've put in. Well, you know that the net work is equal to the heat energy I put in minus the heat energy that I expel over the amount of heat energy that I put in. So they just rearranged all of this. So really the only thing that you need to be aware of is you know how to do thermal efficiency equals net work over the amount of heat put in, and you know to find your net work, you have to subtract the 2, you'll be good to go. Go to the next one.
Don't forget to donate.
Okay, so let's look at an example here. We have the small gasoline-powered engine of a leaf blower absorbs 80 joules of heat energy from a high-temperature reservoir and exhausts 700 joules to a low-temperature reservoir. What is the engine's thermal efficiency? Okay, well first they're asking me to calculate thermal efficiency. And we know that our equation for that is that funny little E that stands for thermal efficiency is equal to the net work over the amount of heat that I got from, that I'm putting in. It's the amount of heat that is being absorbed or that I'm trying to put in. So first thing that I need to do is I need to find my net work. And my net work is equal to the amount of energy that I absorb or the amount of energy that I put in minus the amount of energy that I'm releasing or the amount of energy that I'm getting out. This is what your problem says. The engine of a leaf blower absorbs 800 joules. That 800 joules is the amount of energy that's being put in to the engine. So my QH here is the amount of energy that's put in, so I'm going to put 800 joules here. Again, my QC is just going to be the amount of energy that's being expelled from the engine. That's the amount of energy that's being released. And it says that this small engine exhausts 700 joules to a low temperature reservoir. So my QC here will be 700. So then I can find my net work by taking 800 minus 700, which is 100 joules. So that gives me my net work, so I can just plug that in up here. Now you already know your QH because you just found that to get the net work, and we know that the engine is bringing in 800 joules of energy. So I know my QH is 800 joules. I'm putting in 800 joules to try to make this engine work. So to find my thermal efficiency, I just take 100 divided by 800, and you would get 0.125. If we made that a percent, it'd be 12.5%. So that means that this small gasoline-powered engine only has a thermal efficiency. It's only efficient 12.5%.
That sucks.
Really low. Yeah, it's very, very, very low. Okay, so I would consider this to be a pretty simple problem for one of these thermal efficiencies. So let's do another one.
Do it.
Okay, a gasoline-powered water pump can pump 7.6 times 10 to the third kilograms of water from a basement floor to the ground outside the house in each hour while consuming 1.3 times 10 to the 6 joules of gasoline. Assume the basement floor is 3 meters below the ground. I'm going to have 2 steps to this problem. On A, I want to know what is the thermal efficiency of the water pump. And on B, I want to know how much heat is wasted to the environment in 1 hour. Let's look at all the variables that were given. So it says that a gasoline-powered water pump can pump 7.6 times 10 to the third kilograms of water from a basement. So my kilograms here, 7.6 times 10 to the third kilograms, that's the mass of water that I have. This says that in each hour we consume